we've been hearing a lot about how EBS has enabled so many customers to move into the cloud over the last 15 years. And as more customers move their businesses to the cloud, of course, data resiliency becomes a very crucial aspect and arguably one of the more important ones. Back with you again. My name is Adrian. I'm joined with David, and I understand our co-host Heather is super psyched to be here. Is that about right?
I am super psyched to be here with you guys. Thanks so much for having me. My name is Heather Horbachuck. I'm a principal product manager here in AWS.
So Heather, how do you think about resiliency?
Well, when I think about resiliency, what we're really talking about is making sure your application is there for you when you need it. And for that, your workload needs to be able to mitigate disruptions or recover quickly from them, minimizing the impact to your customers and to your business.
You know, when you say disruptions, a lot of things come to mind. What are the type of disruptions that you're thinking about when you use that word?
Well, disruptions can really happen in multiple forms. Component failures are a pretty typical type of disruption that you can see, and that can take, maybe it's a server crash or a drive fails, and drives can fail in different ways, whether it's a hard failure or a slow degradation over time. You can also have, outside of the data center, you can have infrastructure failures. Maybe it's a power failure when a storm comes through the area, or a flood or a fire in the data center. There also could be non-physical disruptions, such as load stress. So maybe you have an unexpected demand surge when your product is super popular, or you have a DDoS attack. So when you're building these resilient workflows and this resilient architecture, you really need to think through what are the potential disruptions that you can see, because they could take a number of different forms and have a different impact on your workloads.
Yeah, you're reminding me of some earlier roles where we didn't plan for those and wondering what you have to show us how we can be a little bit better prepared for these types of situations.
Well, first of all, I really think that you really need to do a resiliency assessment and understand what disruptions you could have or what potential risks you can have. Generally, we think of it in three different distinct buckets. The first is understand those risks and potential disruptions, and really think hard about the hard dependencies that can translate into an interruption in your service if something goes wrong. Perhaps you can turn those hard dependencies into soft dependencies, and you can compensate for that failure in those dependencies in your design. The second stage is really minimize the scope of that impact, right? Ask yourself, if this application was unresponsive, what are the downstream consequences? What else is going to be impacted? Is it going to be your end customers? Third is plan and automate that recovery. So if your service is impacted, how quickly can you come back up? So as you build things in the cloud, it's really important to be aware of how those disruptions are and how you can recover quickly from them.
Dave, anything coming to mind for you, as we talk through this?
Well, so all the disruptions that you mentioned earlier can happen whether it's on-prem or in the cloud. So how should customers think about resiliency differently when managing storage on-prem versus the cloud?
Yeah, like you said, these things can happen both on-prem or in the cloud. But for on-prem, it's going to be harder and way more expensive to deal with. In an on-prem environment, you're responsible for the entire stack, from your application all the way to managing the underlying infrastructure, such as your data center facilities and your networking. This means you're going to need to be thinking through things like hardware lifecycle, data center space constraints, and the financial impact of carrying that space, that extra capacity. Additionally, if you have multiple facilities, whether it's across the parking lot or across town, you're going to need to think through any shared default domains that have creeped in. So running your on-prem environment means that you can't just be the expert in your application, but you're also going to need to be an expert from the mains all the way up the stack.
Yeah, which is a big contrast with the experiences in the cloud.
Yeah, totally. With AWS, actually, you can actually let us be the experts, the infrastructure experts. You can spend time, instead of concentrating on the infrastructure, you can let us deal with that while you spend your valuable resources adding to your business.
Yeah, exactly.
So I will say one of the most important advantages of the cloud when it comes to resiliency is the avoidance of a single point of failure in your physical infrastructure. It's one of the bedrock principles of the services that we design here in AWS. And one of the best ways to explain that is to talk about availability zones. They typically consist of multiple data centers located in the same regional space that allows us to take care of high throughput and low latency networking. But availability zones are going to be physically independent. They have independent connections to utility power, standalone backup power sources, independent mechanical services, and independent network connectivity. And so we take availability zone independence very seriously. And that's going to allow our customers to take advantage of the multiple zones as they're building for resilience.
Yeah, I don't know about you, Dave, but for me, this kind of awakens some memories. Back in the day, running data centers, running operations, makes me wonder, among the different components of the resilient system, storage is going to be fundamental to just about every application, especially for our enterprises. Where does EBS fit into this? And can you explain to us a little bit more how EBS is designed for resiliency?
Sure. So EBS is actually the network attached block level storage that's attached to your EC2 instance. And we're built as a very large distributed system with many, many components. We've thought hard about building EBS for resiliency with built-in redundancy and fault reduction. So when customers create an EBS volume, for example, our service is going to automatically choose the set of storage nodes to host your volume. And those storage nodes are chosen specifically to ensure the availability and durability characteristics for each of the volume types. Your volume is then going to be continuously monitored for degradation and repaired if necessary. Part of our resiliency strategy also includes separating the volume lifecycle control plane, which is going to control things like creating your volume or attaching it to your instance, and from the storage data plane, which is going to include the components of driving the I/O to your instance and persisting it to durable media. So what that means is once a volume is created, it's going to be independent from your control plane functions, even in the case of an infrastructure event. So if there's a fire or a flood in the infrastructure, you can still recreate your volume from a snapshot. So we've definitely spent a lot of time iterating and improving on the service to take care of the underlying infrastructure so you don't have to worry about it.
Yeah, hard agree there, for sure.
So I want to actually go into what are some capabilities on EBS that we can help improve our data resiliency. So the first thing I want to make sure that customers are thinking about is as they're building their workloads, think about, hey, how critical is your workload, and what's that context for that? If your volume is near and dear to your heart, what I'm going to say is make sure that you're building on our premium product types, our high resiliency, or sorry, our high durability volumes and our high performance IO2 and IO2BX. Sorry, I guess I should jump back and talk about, hey, like how should we think about this? The context of your workload is going to be super important, and so you should really think through, is it important, and pick a volume type that is important to your thing. The next step, I really want to make sure that you are backing up your volumes.
We're supposed to do that?
That's a good call. It is super important to back up your volumes. And with EBS, we come with a fully managed built-in backup capability with EBS snapshots. It's an important pillar of our resiliency. And so it's going to be a point-in-time copy of your EBS volume that's stored in S3. Snapshots are a regional service, which is going to mean that internally we're using multiple availability zones to replicate your data so that snapshots can withstand the failure of an availability zone. And they're going to contain all the necessary data to recover volume, so you can use snapshots to create new volumes or move volumes across availability zones.
So what's the recommendation, Heather, on how often snapshots should be taken?
We recommend that customers take snapshots at least daily. And we have ways to make that easier for you. So which kind of goes to the next point. EBS, or AWS has multiple options for helping you to manage your snapshots. You can do this while using the AWS console or CLIs to create or delete copy. But we also offer DLM, Data Lifecycle Manager, here in AWS. It's a free tool that lets you create policies and automate the process of snapshot creation. Additionally, we have AWS Backup that can help you automate backups across many storage types, including EBS.
So you're saying somebody doesn't have to sit there and write a cron job or some sort of automation to go through and start pruning stuff. We're going to take care of that for you.
Yeah, definitely.
That's awesome. What can you tell us about redundancy? Is that something you can get into?
Yeah, definitely. So it is super important to build redundancy. And first off, I want to say, like, on-prem, I know a lot of customers like to RAID 1 for higher durability. But in EBS is considered, we're a large distributed system. And so if you RAID 1, parts of your volume can be co-located on the same host, making it in a shared fate situation. So RAID 1 is not the best practice. Let EBS handle the redundancy at the storage layer, and instead you should concentrate on building redundancy across availability zones. And because that's the most important thing, there's actually a lot of flexibility in how you can build that resilient architecture. So the most effective way is going to be building at the application level. So a lot of commercial applications already have that functionality built in. You can also build at the OS level using a tool like DRDB, or you can snapshot to create volumes across AZs. We also have a service here in AWS called Elastic Disaster Recovery, and it's a really good option if you have an RTO of minutes. So you can recover your data from the most up-to-date, or you can a previous point in time.
So as part of a customer's resiliency strategy, they should make sure they continuously monitor volumes for disruptions and have a recovery strategy when these disruptions occur. So what are some of the best practices for monitoring?
Yeah, definitely. You should definitely be monitoring your volumes. On the monitoring side, you can take advantage of CloudWatch metrics. Here in EBS, we actually vend a per volume metric with a 1-minute granularity, and that's going to be free of charge. You can use these metrics to monitor various aspects of the performance of your volume, such as latency or queue depth, and you can also actually use these metrics to build automated recovery actions. So you can set an alarm based on a threshold of this metric, and then use a Lambda function on top of it to build a recovery workflow.
Okay, so we got the monitoring bit, we got the observability bit, and it's important to know all the bits that you do have, but as we continue to see distributed systems get more and more complex, it gets a lot more difficult to anticipate those disruptions being even more challenging. You know, the bigger the bird nest, the harder to unwind. I know chaos engineering is a disciplined approach to unhide the failures before they actually become a thing. Any chance you can share some best practices for testing that I promise I'll totally write down and do?
Yeah, definitely. If you don't test, how do you even know if your application is going to respond well to these disruptions? So actually, earlier this year in January, EBS launched Pause I/O actions in fault injection service. So it's going to allow you to test if your volume were to become unavailable from a few minutes up to a couple hours, allowing you to see how well does it respond to those short disruptions, or test your recovery processes during the longer disruptions.
That's awesome. You know, don't have to go through and just like disconnect or detach an EBS volume. But as we continue to go, is it important to do this testing in different accounts, or is it just like let it filter down and then see what happens?
Definitely, we recommend you test in a test account. Additionally, like one of the best practices is to make sure, like as you continue to build your application, make sure that you are continuously testing as your application changes.
And how about best practices to try to speed up that recovery?
There's a few additional features in AWS that can help you accelerate that recovery. So like I said, snapshots is going to be one of the critical pillars in your resiliency strategy. And then for latency sensitive critical applications, you can use fast snapshot restore to recover volumes from a snapshot quickly. Additionally, I know earlier we talked about using the CloudWatch metrics to set a Lambda function and help you recover. But you can also use your CloudWatch metrics to trigger. You can also use You can also use EC2 auto recovery, which triggers based off those CloudWatch alarms, or you can use auto scaling groups. Those are both going to be good ways to help you recover. The thing I would note about auto scaling groups, though, is it's going to help you. It's great if your workload can recover in a few minutes, but if it's going to use the same APIs that you would use yourself. So if there's going to be an issue with the underlying API, the auto scaling group may not work for you. Additionally, the third thing I would say is for disaster recovery, like we talked about, copying snapshots across AZs or across regions is a super common way. So that's going to be a great way. So all these features can help you fine-tune your recovery workloads, but I want to point out that the single most important feature of recovery is that you must have a failover plan, and you have to know when to use that failover plan. So make that decision up front, what your triggers are, what are your recovery workloads, know how long to wait. So bottom line, separate your ability to recover from our ability to recover, and it's going to be the best way to build a resilient architecture.
Thank you so much for your time, Heather. It was extremely illuminating, and thank you everyone for tuning in. Please stay tuned. We've got some additional exciting content coming up for you. Thanks so much.